A block is simply released from the top of an inclined plane as shown in the figure. The maximum compression in the spring when the block hits the spring is. This is the given diagram. Initially a block is placed on the inclined plane. Given angle of inclination is 30 degrees and the length of this inclined plane is 10 meter. Mass of the block 5 kg. Length of the inclined plane 10 meters. Angle of inclination 30 degrees. This block is gently released. That means what is the initial velocity of this block? Initially the block is at rest position. Whenever this block is released, it is moving along the inclined plane and after then it doesn't stop. It is moving along the horizontal surface. But this horizontal surface is a frictional surface. There is no friction along the inclined plane, but this horizontal surface has the friction. Coefficient of friction is equals to 0.5. Whenever this block hits this spring, it is compressed. We have to find out the maximum compression of the spring. But in this question, we have to take one assumption. Otherwise, we are not getting the exact answer. What is that assumption? The frictional force acting only up to this 2 meters. The place which is occupied by the spring, there is no frictional force. That is the main assumption in this question. To solve this question, take the work energy theorem. Here frictional force is non-conservative force. Take the formula. Work done by the non-conservative force is equals to change in potential energy plus change in kinetic energy. Initially block is at rest position. After compressing this spring, again the block comes to rest position. That means final velocity also equals to 0. Final velocity 0, initial velocity 0. Then what about the change in kinetic energy? 0. Work done by the frictional force is negative. Minus frictional force into distance travelled by the block. Minus Fs equals to change in potential energy. Final potential energy minus initial potential energy plus and also energy stored in the spring. Half k x square. This is plus sign because initially there is no compression. Only it has the final compression. So take the formula of k x square, where x is maximum compression of the spring. Change in kinetic energy is 0. Frictional force is equals to coefficient of friction into normal reaction. Normal reaction applied on the block is equals to mg. Minus mu mg into s. Final potential energy is 0 because block reaches to the ground. There is no height. Minus initial potential energy of the block is minus mgh plus half k x square. Height of this inclined plane. Find out the height of the inclined plane. Sin 30 degrees is equals to height of the inclined plane by length of the inclined plane. Given length is 10 meters. H equals to 10 into 1 by 2, that is equals to 5 meters. Minus friction 0.5. Mass of the block 5 kg. Take G value 10 meter per second square. Actually G value is not mentioned in question. Then we have to take 9.8. But when we take 9.8, we are not getting the exact answer. That's why take 10 meter per second square. These two are assumptions in this question. Here S is equals to 2 meters. Distance travelled by the block along the horizontal surface is 2 meter. And here height of the inclined plane is 5. Plus given spring constant K is equals to 100. 100 into x square. Take 10 common and cancel on both sides. 10, 10. Here also 110 get cancelled. And also take 5 common and cancel on both sides. 5, 5. Here 5 2's 10. This 2 and this 2 get cancelled. The remaining terms minus 0.5 into 2 minus 1. Here minus 5 is remaining. Here x square. From this x square is equals to minus 1 plus 5. Minus 1 plus 5 equals to 4. Then x equals to square root of 4, that is equals to 2 meters. The maximum compression of the spring is equals to 2 meters. Third option is correct. So you should remember two assumptions in this question. Frictional force is acting only up to this 2 meters distance and G value is 10 meter per second square.